Hi, my name is Burak Bulak, and this is my Physics 211 project presentation. In this experiment, we developed a Fourier optical system using a Fourier correlator, and we managed to see the Fourier transforms of the several objects and their corresponding inverse Fourier transforms. Now, here's our exact setup that we used.
Here's the exact setup that we used in Ankara University, and since it is not easy to understand it here is the corresponding simulated version of it.
Here, first of all, the tiny laser beam spread out with the circular aperture's pinhole, which we used 0.3 millimeters of diameter. Then the mirror system reflects the laser beam through the lenses. And in this part, we introduced the object mask so that the processed laser beam arrives to the first lens, which we used 15 centimeters of focal length, and then to the second lens, which we used 20 centimeters of focal length. So you can see that it distinguishes from the classical Fourier correlator system. Then it arrives to the image plane.
In this experiment, we take the Fourier and inverse Fourier transforms of 4 different object masks, and you can see the one for the circular aperture. You can clearly spot the Avery disks, and here is the inverse Fourier transform of the corresponding circular aperture one. And here is the Fourier transform of square aperture, which you can see the crossed sinc functions and also the desired inverse Fourier transform of it. And here's our crossed arrow object mask and its corresponding Fourier transform, and also the inverse Fourier transform. And we also want to show and apply the same principle for a real image, so we use this one, and here is its Fourier transform and also the inverse Fourier transform. At this part, we also wanted to apply a filter operation, so we first use the adjustable width slit and also 3-zone Fresnel, which acts like a circular bandpass filter. Here you can see the image plane of the cross arrow object mask while we are adjusting the horizontal slit. And after we applied the horizontal width slit, here is the Fourier plane of the same object while we're using the adjustable vertical width slit. And in addition to that, here is the image plane of the image film while we were using the circular bandpass filter. As you can see, most of the lights and also the patterns are unrecognizable right now.